Welcome to a special deep dive on AI Unraveled. Today we are talking about physics, specifically the physics of your budget. We are exploring the concept of data gravity. It's the single biggest friction point in enterprise AI today. You have massive data sets, petabytes of video, logs, and customer data, living on the edge or in private centers. The cloud providers want you to move it all to them for training and inference. But here's the reality check. You can't. Physics, economics, and the law are standing in your way. We're seeing companies burn 30% of their AI budget just on egress fees, moving data back out of the cloud. We're seeing latency kill real-time applications. And we're seeing new regulations like the EU AI Act force data to stay within national borders. In this episode, The Cost of Data Gravity, we are ripping up the cloud-first playbook. We'll explore why the future is hybrid, how to use federated language models to split the brain from the brawn, and why the smartest move you can make in 2025 is to stop moving data to the model and start bringing the model to the data. But before we start marketing to the masses, start briefing the C-suite. You've seen the power of AI Unraveled, zero noise, high signal intelligence. Now, leverage our proven methodology to own the conversation in your industry. We create tailored, proprietary podcasts designed exclusively to brief your executives and your most valuable clients. Stop wasting marketing spend on generic content. Ready to define your domain? Secure your strategic podcast consultation now. Link in show notes. Now let's solve the deployment nightmare.
Welcome back to the deep dive. So, if you're in enterprise tech right now, you are absolutely living through the generative AI gold rush.
Oh, for sure.
We're talking about, genuine cognition, automation at a scale we've never seen, and it's completely redefining how we interact with technology. It feels like this irresistible force.
It is. That momentum is just undeniable. But, and this is the big but, as architects and engineers are discovering, that irresistible force is running headfirst into an immovable object.
Unmovable object.
And that friction point, that's where the biggest profits and honestly the biggest disasters are going to happen over the next couple of years.
Okay, let's unpack that. We've all felt the hype. So what is this immovable object that's causing all the friction?
It's the immutable physics of data gravity. And it's not just a metaphor anymore. It's a real quantifiable economic reality.
Data gravity?
Yeah. Data sets have become so massive, so heavy, that they literally attract everything around them. Applications, services, processing power. And if your data mass is too big, moving it just becomes prohibitively expensive and risky.
And this collision AI hitting the sheer density of the data, this is what we're calling the hybrid AI deployment crisis. Because CIOs, CTOs, they're still operating on that old cloud-first playbook.
Yeah.
And it just seems fundamentally broken for the kind of data AI needs.
Exactly. The old strategy was simple, right? Just pipe all your data to a central cloud, train your model, and you're done. Data gravity shatters that. So our mission today is to go beyond the hype and really dissect the hard infrastructure realities of 2025.
Okay.
The core challenge we have to solve is, well, it's learning how to bring compute to the data instead of drowning in the cost of moving all that data to the compute.
Let's start with the physics then. What exactly is making data so heavy all of a sudden?
It's really a triple threat. It's volume, it's location, and it's the type of data. So first, the volume is just astronomical. We're in what you could call the data-powered economy now.
Right.
Global enterprise data is forecast to hit 1.2 million exabytes in the next 3 years. I mean, that growth rate alone is going to strain any infrastructure.
An explosion. But here's the detail that turns it into a hybrid nightmare, not just a cloud scaling problem. Where is all this data actually being created?
Overwhelmingly, it's outside the public cloud. You need to just hold on to this number. 93%. 93% of new data is created at the edge.
93%. Wow.
Yeah. Think about it. It's factories, smart cities, hospital MRIs, retail cameras. The cloud is where the big models are trained, for sure. But the inference data, the real-time stuff you need to actually use the models, is being born right where the action is.
And it's the nature of this data that's the real issue. We're not talking about, little transactional logs anymore.
No, not at all. Gen AI thrives on heavy, unstructured data. Video feeds, high-res images, massive audio files. Moving a few megabytes is nothing. Moving petabytes of 4K sensor data across a network for real-time inference, it's physically impossible and economically absurd.
And that strain is starting to hit the physical limits inside our own data centers.
Oh, we're seeing these compounding effects. First, network bandwidth is just saturated. It's creating what our sources call data swamps.
Data swamps?
Yeah, data that's just trapped because the pipes are clogged. And second, the power required is surging. Rack power densities have doubled to 17 kilowatts in just a few years. Cooling demands are at crisis levels.
Which means companies literally can't even get their projects started.
Exactly. It's the definition of friction. We're seeing data that shows 44% of enterprise leaders say IT infrastructure constraints, power, cooling, bandwidth. That's their number one barrier to expanding AI. They have the models, they have the business case, but they don't have the electrical outlet.
Okay, so the physics are against us.
Correct.
Let's move from the physical to the financial then. The economic nightmare of cloud egress. You describe the public cloud as a Hotel California scenario.
Because you can check your data in anytime you like, but you can, for all intents and purposes, never leave without paying a huge tax. These egress charges, the fees for moving data out of the cloud, they've become the silent killer of AI ROI.
How silent are we talking? What kind of a drain is this on the bill?
For data-heavy Gen AI apps, these fees can account for up to 30% of your total cloud AI spend. Think about that, almost a third of your budget, just moving bits across a wire. It adds zero value.
That is staggering. Let's get into some of the real-world examples because this is where the theory becomes, a very painful reality.
We saw some really striking ones. There was a fast-growing SaaS company. They relied on a lot of image data. Their egress costs jumped from $200 to $3,500 a month in just 8 months.
Wow.
And that wasn't even for training. That charge surpassed their compute costs by 40%. It was just because users were interacting with the images. So the more successful they got, the more they were taxed.
So success actually becomes a financial penalty.
Yeah.
What about automation surprises?
Right. A data analytics firm automated daily exports to third-party dashboards for their clients. Seemed harmless. But that automation led to $2,800 a month in egress charges. That was a quarter of their entire cloud spend, a total financial hemorrhage they never saw coming.
And maybe the scariest one is how this turns disaster recovery into, a vulnerability.
The manufacturing company example is alarming. They ran one single disaster recovery drill, just 15 terabytes of data, and they got hit with a $1,200 unplanned egress charge.
Ouch.
This really crystallizes the problem. The data you've stored and protected becomes, in effect, ransomware. You have to pay the host a fee to get your own assets back in an emergency.
This has to change the whole CapEx versus OpEx conversation, right? If we move compute to the edge, that's a big upfront investment.
Exactly. The old cloud model was low CapEx, high ongoing OpEx rent fees. Edge AI demands high upfront CapEx. I mean, you might need to spend thousands of dollars per unit for specialized hardware.
Wait a second, though. If we're spending thousands per unit on hardware at the edge, aren't we just trading a predictable OpEx nightmare for, a huge, unpredictable CapEx and maintenance headache? Is the ROI really there?
That's the critical question. And the answer is, in managing the intelligence, what the industry calls tiered data processing, organizations using hybrid architectures are reporting real, verifiable 15 to 30% cost savings. The upfront investment pays for itself because the ongoing savings are so huge.
Okay, so give me a specific example. How does tiered data processing work?
Think of a factory floor with 20 cameras. The edge hardware processes all 24 hours of video locally. It filters out 99% of the noise, the shadows, normal movement, and it only sends the high-value signal, maybe a 30-second clip of an anomaly. That goes to the cloud.
So you're not piping petabytes, you're sending megabytes.
That's how you justify the CapEx. And the economics get even more skewed when you look at the hidden tax token pricing. This is the final nail in the coffin for cloud-only inference at scale. Compare a proprietary model like GPT-4. It costs around $30 per million input tokens. Now compare that to an open weights model like Llama 3.8b that you self-host. The cost plummets to about 3 cents per million tokens.
That's literally 1,000 times cheaper.
A 1,000-fold difference. It confirms the conclusion. The cloud is great for R&D, for sporadic planning, but for continuous high-volume work running a production line, monitoring retail, the edge or self-hosting is the only economic path forward.
Okay, so shifting from the ledger to the clock, our third friction point is latency and performance. Even if money weren't an issue, the speed of light is a non-negotiable constraint.
For safety-critical systems, latency is everything. A cloud round-trip time, sending a request, processing, getting a reply is maybe 500 milliseconds to a few seconds. Edge processing is consistently under 100 milliseconds.
And for something like an autonomous vehicle or a robot,
you need sub-50 millisecond response times. The physics of network travel just mean the cloud is not an option, period.
And it's not just the raw speed, it's the consistency, what engineers call jitter.
Correct. Cloud functions have cold start problems, you're in a queue for resources, you're competing with everyone else for GPU time, and that creates variable response times. Jitter. A local small language model, an SLM, gives you deterministic latency. The hardware is dedicated. It's predictable.
This is where it gets really interesting on the data side for me. Vector gravity. So RAG retrieval augmented generation is the backbone of almost every internal Gen AI project. But the vector databases create their own bottlenecks.
They absolutely do. RAG relies on comparing a query to this massive index of your company's knowledge, and vector search is incredibly memory hungry. We see two big latency issues here. The first is indexing latency. Just building these massive indexes, a billion vectors or more, can take days.
And if it takes days to build, you have an instant data freshness problem.
Exactly. If your business data is changing fast like live inventory, your index is always out of date. And then there's the larger than RAM problem. For SMED, these indexes have to be loaded entirely into RAM.
And if the index is bigger than the RAM you have,
The system starts swapping from disk, which is orders of magnitude slower. It just kills performance. So running it locally is great. It eliminates network hops. But now you have a new hardware constraint. You need specialized edge hardware that can fit that entire heavy index in its memory.
so we have physical gravity, economic gravity, performance gravity. Let's layer on the fourth, legal gravity. Regulation is basically an artificial, forcing this, balkanization of the global AI landscape. A splinter net.
Yeah, data is being pinned to specific jurisdictions. Look at Europe. The EU AI Act classifies systems by risk. High-risk apps in HR or finance face incredibly strict governance. That means the data handling and model usage have to be fully auditable.
And the conflict between GDPR and U.S. law is making U.S.-hosted LLMs legally risky for European companies.
That's because of the U.S. Cloud Act. It can compel a U.S. provider to hand over data no matter where it's stored. So for any European company with PII, personal identifiable information, moving that data to a U.S.-controlled LLM is a huge legal exposure. It forces those workloads to the edge or onto a truly local sovereign cloud.
That regulatory pressure also makes relying on proprietary black box cloud APIs a really tough sell.
Absolutely. If liability is tied to the developer, like some new laws are proposing with mandatory kill switches, you just can't afford to hand over control of your core intelligence. You need verifiable control.
And we have to talk about the security risks in just moving the data, which fuels this whole shadow AI problem.
Every time you move data, your attack surface expands. You risk training data leakage, where the model memorizes and spits out sensitive info. And then you have attacks like prompt injection, tricking the LLM into revealing internal data.
And frustrated employees, they just find the path of least resistance. They go use public tools.
And that's shadow AI. Gartner predicts that this explosion of unsanctioned public Gen AI use will cause security incidents at 40% of enterprises by 2030. They already found that 69% of organizations suspect it's happening right now.
So to navigate this, there's a critical distinction executives have to master. Data residency versus data sovereignty.
Yes. Residency is just the physical location. The data center is in Frankfurt. Sovereignty is whose laws govern the data. A U.S. cloud provider with a server in Frankfurt meets residency, but because they're subject to the U.S. Cloud Act, they do not meet sovereignty requirements for, say, a German bank. That distinction is fueling the entire demand for sovereign clouds.
So with all this friction, the old model send everything to GPT-4 is basically dead for big enterprise.
Yeah.
What are the new architectural solvers? What actually works?
Architects are adopting these hybrid patterns that split the workload, and the most powerful tool we have is the federated language model. People call it the brain and brawn split.
Okay, tell us exactly how that split works and how it keeps private data private.
So the big, powerful cloud LLM acts as the planner, the brain. It gets a sanitized, abstract prompt, something like, tell me the average sales for our top 3 clients in Asia last quarter. Critically, it's abstract. The cloud LLM never sees the raw client names or the sales figures.
And the edge SLM is the brawn. It handles the actual work.
Exactly. The cloud LLM sends back a plan. Step 1, identify top clients. Step 2, query the local database for sales figures. Step 3, calculate the average. The small language model, the SLM running locally, gets that plan and executes it against the local secure RAG database using the full private context.
So you get the cloud's powerful reasoning to how to solve it without exposing the raw private data to what the data actually is.
That's how you beat data gravity while still getting high-end intelligence. And a similar pattern is hybrid RAG. Here, the vector database and all the documents live on-prem, retrieval happens locally, Only the relevant snippets, which you can anonymize, get sent to the cloud LLM for final synthesis.
And this is all validated by the fact that small language models are just getting so much better. Bigger is better isn't really true anymore.
No, the performance of models like Llama 3.8b or Microsoft's Phi 3 is remarkable. They can handle 80% of routine enterprise tasks, summarization, extraction, categorization, all locally. It eliminates the token tax and solves latency for most daily work. It just reinforces that federated model. Use a local SLM for routine stuff and save the expensive cloud LLM for truly complex reasoning.
So this all comes down to a strategic inversion.
Yeah.
Stop fighting gravity, push compute to where the data lives, and we're seeing the big data platforms race to build for this.
Yeah, we're seeing two distinct strategies emerge. First is the loose coupling approach. Databricks Lakehouse Federation is the best example. They let you query external databases, MySQL, Oracle, whatever, without moving the data.
So Databricks handles the governance, but the processing gets pushed down to the source. The data stays put.
Exactly, they respect gravity. The second, tighter approach is from Snowflake with their Snowpark container services. With Snowflake, they want the data in their warehouse first.
And once the data's in Snowflake, how do they solve the problem?
They let you deploy containerized LLMs like Llama 2 or Mistral inside Snowflake's security perimeter. This is a huge advantage. It eliminates egress fees and security issues for data that's already consolidated in their system. They're basically turning their data warehouse into an AI platform.
And none of this works without a hardware renaissance to meet that edge CapEx requirement.
For sure. And the market is responding. We're seeing specialized edge silicon like the Halo 8L that gives you AI acceleration at a fraction of the power and cost of a big server GPU. This makes sophisticated AI on cost-sensitive devices like in retail actually manageable.
So what does this all mean for you, the listener? We've gone from big data, centralized, static, to heavy data, distributed, dynamic, generative. What are the four pillars for mastering this hybrid AI nightmare?
First, respect gravity. Stop trying to pipe petabytes. Move the inference model to the data source.
Second, diversify intelligence. Don't rely on one giant model. Orchestrate a fleet. Large central LLMs for planning, small local SLMs for secure execution.
Third, federate data. Leave the data where it is. Use things like Lakehouse Federation and hybrid RG to access data in place. Avoid that egress tax.
And finally, sovereignty first. You have to design your architecture for the strictest regulatory environment you operate in. It's always easier to loosen controls later than to try and retrofit them.
Mastering the art of bringing the right compute to the right data at the right time, that's the competitive fortress for the next decade.
Which leads us to our final provocative thought. If data gravity defines 2025, what defines the end of the decade?
I believe it's going to be energy gravity. Data centers already consume a massive amount of electricity, and AI is only going to increase that. Eventually, the best place for these huge compute farms won't be near the users, but near the cheapest, cleanest, most abundant power. Think hydroelectric dams, nuclear plants. Energy gravity, not just data gravity, will determine the final geographic location of our digital world, adding yet another layer of complexity to everything.
A fascinating convergence of physics, power grids, and pure processing. Thank you for guiding us through this essential deep dive.
And that wraps up our deep dive into data gravity. If you take one thing away from today, let it be this: respect the gravity. Stop trying to fight physics by piping petabytes of data to a central brain. It's too slow, too expensive, and increasingly illegal. The winning architecture for the next decade is federated. Keep your heavy data where it lives. Use small, efficient models at the edge for the heavy lifting, and only call the massive cloud brains for the complex reasoning tasks. Your goal isn't just AI everywhere. It's the right compute at the right place at the right cost. For the full decision matrix on cloud versus edge and the cost breakdown, check the show notes. And don't forget to subscribe to our free daily strategic briefings on Apple Podcasts. If you are ready to lead the conversation in your sector, click the link in the description to book your strategic podcast consultation with me. This podcast is researched, produced, and hosted by Etienne Noman, senior software engineer and passionate soccer dad reporting from Canada. Until next time, stay strategic. This is AI Unraveled.